On your phones, assuming you have a reasonable capable phone, you should be able to go to game.rem.io, and there you'll find a alert box that will ask you to stick your photo into the game. So what I'm going to do is, contrast's not great, but we should see people kind of appearing on this. So I'm going to take a photo of myself. In fact, yep, that's me. Has anyone else got their photo up yet? The aim of the game is to hit people's face that have the same color. So I'm winning, of course, because I am the creator of the game. The game is not very playable. It was an experiment, but the point is, with just a few lines of code, we've got this kind of real-time streaming over the web. And the thing is, the color changes really quickly, and it's okay to play. How are we doing? Yeah, cool. That photo at the top, I'm not convinced is an upload from your camera. So everyone sees that a little bit. This was built within maybe 6-7 hours worth of work. Very small piece of code. Most of the code, because I'm a developer, was the rounded circles and the spinning thing. So if you hit someone, it kind of spins away. Oh, if you hit yourself, that doesn't work. Yeah, so very small amount of code. I'm going to show you some of this now. Okay. And also, if you find my talk boring, you can just keep playing the game, right? So, right, this is the client-side code. Let's make this bigger. Right. So if anyone's used anything like Socket.io, this is very similar to Socket.io. If you haven't, don't worry, it's pretty straightforward. You have a JavaScript library that gives you this object called Primus, and we're going to connect to a server. And that creates our persistent socket back to the server. I'm going to talk about how you scale those kind of things, but just like, this is now a persistent socket to the server. And I'm saying, when there's this particular event called warning, show the data. So the server's going to say, there is some warning data, like you've just been hit in the face, or your score has changed, or something like that. And I've basically broken the code into lots of little events. I could just have one. With WebSockets, you have just an on-data event where it just chucks all the data down one event. This is just broken up for me, allows me to just split my code up a little bit, basically. So, for instance, the remove event, remove is in the game UI. So remove is just, the server tells me that a user is disconnected from the game. It emits an event to everyone to say this particular user has been removed. So it gives me the ID of the user, and I go ahead and actually get rid of that user on the screen. Right? Just a bit of jQuery, find that class. This is just the animation, so the hide spinning thing. Same thing with a score. Same thing with a count. So count is basically the server saying someone is connected to the server. I'm going to emit an event that is the total number of persistent connections to the server. And we should see, if I go to game.rem.io, up in this corner, we have like 22 sockets, 23. So as that number goes up, that's the count event. So it just emits this thing with a number. I get a real JavaScript object. Really straightforward. And the server side, there's quite a bit to it, but it's logic to say, can I, like the hit thing, can I hit myself? Do I have a face yet? But if we look for the emit count total, there you go, broadcast count. There you go, so broadcast I'm sending to everyone. So I just send the total number of connected objects to the server. And for 24 hours, or less than 24 hours, for something that works, I've got streaming servers on, working over mobile, working over different devices, and it can degrade and so on, and it wasn't very much work. But the point is, real-time is super easy now and expected by your users. So I was reading a Wired magazine a couple of days ago, and it was talking about this technology called Viv, which is basically the next version of Siri. And Siri can answer questions like, where was President Lincoln born? Or what's his birthday? But it can't answer things like, can you book me a flight for the destination is President Lincoln's birthplace on his birthday? So their new system, their new AI will be able to answer questions like that and actually book flights for you and say, yep, no problem. And it expects to be in cars and phones and computers, and there's going to be like a cloud brain in the cloud. Point being is you can reach for any piece of information and it's just there waiting for you. Google lets us do that, right? We can ask it anything. And some of you probably remember the days that you would hear some music or watch something on the TV and you'd have to wait several days before you could find out more information about it. But everything's at our fingertips today. And the same with, like, Twitter is kind of the crowning example of push information. We're so busy with our lives, we have to have all the information kind of pushed to us in real time. So, on demand is a normal part of the world we live in today. And if we can't do that easily, we're in trouble. But we can. So, Guillermo Rauch, the creator of Socket.io, gave a couple of talks, and I've got some links to go with these slides that I'll publish later. He gave a couple of talks on real-time where he goes to try and define what real-time means or what push technology means, and it boils it down to fast and self-updating, in that the application keeps up to date with all the data that's being pushed to it. I think it's instant, which is maybe a little bit faster than fast, but the point is the data is served to you all the time. You're not asking for it. You don't have to pull to refresh. You don't have to hit refresh to get that data. It has to be delivered to you. It's also important to distinguish between real-time from a technical perspective and real-time to the user. So the experience is the most important thing. There's been some applications that implement like a fake delay because computers are really fast now, right? I think TweetDeck's the example. TweetDeck, when you're converting your accounts from TweetDeck to Twitter, the actual code to do that is instant, right? You just press a button and it's done. But they introduced like a fake delay to kind of allow you to cognitively understand what's actually going on. You need to delay something. It's like transferring £1 million from one account to the other, which I know probably half of you have done before. You don't want to be instant. You want to feel like something happened, right? And I heard about someone talking about Heroku once, where they're dragging. If you ever used Heroku to scale your servers, it's just like that. Suddenly you have 2,000 dynos just out of nowhere. There was a time where you had to fax people and wait. So there is this kind of user expectation. You don't always want it to be instant in that way. So I want to give a little bit of context as to why real-time is particularly interesting to me. And it was 2002. I used to work for a finance company and worked for them quite many years. We mostly did this, knocking around the office. But with finance companies, stock prices are the most important thing, or one of the most important things, real-time prices. And the only way that you could get that at the time was that you would have a license with the London Stock Exchange. You would probably have a dedicated line going into your office, and the closer you were to the office, the better the prices were going to be. And you'd have some Java team working on very special types of technology. And it was very, very expensive. So the next best thing was to poll for prices. Now, this is a snippet of Ajax. We weren't using Ajax in 2002, but this is what it would look like if we implemented it a few years later. Because we would grab prices from Yahoo. They would have like a CSV file that was updated every 15 minutes, and these 15-minute delayed prices, we would have polled it. We would have polled our own servers to say, has the price changed for Microsoft every minute? So at 9:15, our server says, yep, the price is $45. And we poll it every minute because we want to catch it as soon as it changes and push that to the user, or have like the experience of real time. We keep polling and polling. It'll be 9:16, 9:17, 9:18. Price hasn't changed, and eventually 9:30 or whatever time, the price will change. It's $46. The problem is, because it's 15 minutes delayed already, you've got like up to 29 minutes worth of stale data. Okay, it hasn't updated, or we haven't seen it update yet, even though the price has changed. But what's worse is that we're constantly sending requests to the server that we don't need to be doing. The server is the ultimate source of truth, right? It knows when the price has changed, so it should say the price has changed. Here it is. Okay, so it's delivering it to the client side. So we've got 2005. Gmail released with Gtalk, so it turns into Hangouts. I think it was called Talk at the time. So 2005, they have Talk. And this is kind of the birth of Comet. So Comet is the technology that allows us to push data to the client side. So what happened was Google had their Talk application, and the way they were getting chat messages into the browser was by creating an iframe, pointing to the server, and the server would send chunks of scripts that would be, which is basically script. Fred said this, and you type back, and then it long polls, sends up chunks of scripts. But every few minutes or after a while, that iframe would fill up and get bigger and bigger and consume more memory. I mean, you remember this kind of IE6 days and maybe earlier. So they'd have to refresh that iframe, and it would have to close and restart again. Now, the thing is with that is it would make a noise because it was part of the... If it was in XP, it would have the XP suite of sounds, and hopefully my sound works. Can you turn it up? Can you hear that? Right, that's the noise you would hear when the iframe would reload. So if you imagine you're sitting there chatting to someone, and all you hear every few minutes is like click, and then click. What was that? And inside of some iframe, it was refreshing. So Google hired the last few, or I believe they hired the last few Microsoft engineers from XP or IE6 days, and asked them to solve this particular problem, that clicking noise. And what they ended up with was an iframe, of course, with an ActiveX component inside of it, which was an HTML file, which had an iframe inside of that, which then did the long polling, and the ActiveX suppressed the clicking noise. Okay, so Google shipped this, and I can't remember if it was Alex Russell who reverse engineered it, or if it was some other engineer, but the open web community reverse engineered what Google had done, and Alex Russell coined this as Comet. So Alex Russell, one of the creators of Dojo, now works on Blink, super smart guy, lives in the future, that kind of thing. But that was Comet. So we now have this technology that allows us to push content up from the server to the client. I got this a few times. Okay. So Comet isn't a specific technology. It's not like a JavaScript library or anything like that. It's a bunch of technologies mixed together. You can have long polling. You can have different types of servers deliver. You'd have different technologies, different protocols for talking to the client as well. So the Bayou protocol was one of them. Another one was Bosch. And I consider myself a bit of a cowboy developer. Like, I'll copy and paste a lot, and the stuff that sticks is good. This was basically out of my comfort zone. I wasn't prepared to set up servers that had like Twister for Python. So you need an evented server to be able to talk this Bosch or Bayou protocol. There was Juggernaut for Ruby, which maybe some people have used, and Jakarta for Java, I believe. So point is, they'd solve the client side, but the server side was still hard. And there's two parts to this, right? So like mid-2000s, the typical stack is lab stack. And I don't know how many of you are still kind of running with that type of setup, particularly Apache. Apache is not good at doing persistent connections to the server. And the reason for that is that Apache runs, it spawns a bunch of child processes, and it can handle as many persistent connections as there are Apache processes. So if you have Apache spawn 10 processes, it can handle 10 persistent connections, but when the 11th person comes in, they don't get a response. They don't get anything. It just sits there waiting. So that your server will say, yeah, hold on, I'll get Apache to do the job, and Apache doesn't do anything at all. And that's why you need event-based server, which is what we got in 2009. So Ryan Dahl announces, well, it doesn't really announce. Basically, he gives this presentation entitled Node.js Evented I/O for V8. And the talk is still online. It's pretty technical to start off with, mostly beyond me, but I started understanding what he was talking about when what he showed me looked very similar to the DOM, the way the browser works. And that's what clicked for me. So the way that Node works is it has an event loop. This is what an event loop could look like. This is not the Node event loop, this is just an event loop. And this is how browsers work as well. So we've got this initialize, which would be what the browser actually drawing and setting itself up. And it waits for messages. So that message, that get next message could be a click, or it could be an XHR callback, or it could be some JavaScript running, or it can be some other event. And that's why if you have your, when it goes on to process the message, if you have a while true in your JavaScript, when you click, the browser won't do anything because it's an evented machine, basically. It can't move on to the next event because you've tied it up in the process message part. And because of this, Node can take thousands of concurrent requests. It can just grab the request and do like a set timeout or just hold on to the request and then move on to the next message. It doesn't block while it's waiting for the next message to come in. So let me just show you some code that, this is similar to the code that Ryan demoed like 5 years ago, but I've moved into the client side, so it's pretty straightforward. We've got so if this is a client side, if we had a document.write and we have a timer that just writes more stuff to the console, right? So this just keeps spitting stuff into the console every 2 seconds. Pretty straightforward. So I've just added a bit of cruft around this, which turns it into a server, which will accept a connection, and then when it accepts a connection, it'll write back to it will respond with a script tag, and every 2 seconds, it'll respond with more script tags. But the important part is it doesn't end the connection. It keeps it open. It's a hanging server. And a hanging server is what allows us to do long polling with thousands of concurrent requests. So I've got this tick.rem.io, which I can quickly show you. Has to wake up. Okay, so it's the same code, it's doing a bit more DOM stuff. It's just injecting. And the client side won't, like if you do view source, it won't show you because it's trying to get to the end of the page, and there is no end of the page. I haven't closed the connection. So that's what a hanging server looks like, and it's basically the essence of a commit server. And what's awesome about Node is it has first-class support across Mac, Linux, and Windows. So, and it's very, very well documented. You've got lots of stuff in the community. So it's pretty easy to get started with today. This technology that we kind of saw over the time, like the commit stuff, using Flash for sockets. The very first time I saw real time, it was using a Flash interface bridge to talk to a socket. We now have that via XHR. We have XHR2 now. Event source and WebSockets. XHR2 lets us particularly track the progress of uploads and downloads. Really useful. Nothing special is required to be able to do that. You just post to the server and it will tell you how far along it is. I'm a particular fan of event source, but not many other people are for some reason. It's kind of like a dumb version of WebSockets. Event source will push events from the server up to the client. It just does that. It's not two-way. The format for it is a little bit crap. Basically, it's just text. There's no JSON support out of the box or anything like that, but you can push specific events. This kind of thing, to me, is perfect for stock prices, for instance. And then WebSockets is bidirectional, persistent, but what's particularly powerful about WebSockets is out of the box, they support cross-origin. So if you're a .NET house, for instance, it might be hard to convince the DevOps to change all the infrastructure across to Node to be able to do this stuff. But because WebSockets can go cross-origin, you can just introduce a new node box, a single node box, and have all your WebSockets connected to that. So if you're URL is facebook.com, your WebSocket server can be ws.facebook.com. So it can connect to that server, and that server behind the scenes can communicate to your APIs on your .NET server, for instance. So WebSockets has a polyfill, which uses Flash. Event Source has a polyfill that just uses JavaScript. Because of that requirement, I tend to use Event Source and XHR together because I know that some of the stuff I'm doing has to run on really old mobile phones. So some of the stuff that I do with real time. So I run a project called JSBin, if you haven't heard of it. If you're designers, then it's like CodePen, except we were there first. But anyway, we do things like live remote reload, and that works on like really old Android phones because of Event Source. Codecasting, so I hacked together a little demo at the end of this that I'm going to walk through to show you some codecasting, but WebSockets at scale. You can proxy events, so you can proxy events from your mobile device to your desktop. So if anyone remembers, Google did a game last Christmas, I think, like a Crazy Marble game. And what they were doing is they were using WebSockets to stream data from your accelerometer on your phone directly into the desktop. And that's basically proxying events through WebSockets. You've got things like user discovery. Obviously, chat is a pretty common use case for real time. And like push notifications of a process that took a long time to complete. Not so long that it needs to be a cron job, but if you have a job, so GitHub, for instance, when you fork a GitHub repo, it's not like an instant job. It takes a little bit longer on the server side to actually complete. But when you hit fork, it doesn't just like hang and come back to you when it's done. It immediately loads the page and gives you kind of an animated GIF that you can look at, enjoy, while it's actually completing that process in the background. And once it's completed that process in the background, it pushes back into that page and say, oh, I'm done. I'm going to reload the page now. Okay, so because we're not consuming the server with these with the maximum number of concurrent requests, we can keep accepting more connections, and we can serve up pages and say we're actually working on something. And kind of a cautionary point is consider only sending, if you're looking at WebSockets, consider only sending what you need to send upstream. WebSockets are a little bit kind of all or nothing. If you connect to a WebSocket server and you want to if you want to broadcast data to some parts and not other parts, it's quite easy to, like the game that I was showing you early on. So when the scores changed, I was pushing up a scores event, like here's the scores for everyone. I was pushing that into the main scoreboard. That could be easily sent to every one of your mobile devices, which is bandwidth, right? And it slows you down. It also takes up time for your client, like your device, to process that data and not be handling other messages or handling kind of user input and so on. Okay, so there's a few important details. One of them, particularly in the UK, O2 will generally drop WebSockets, which is kind of a bummer. But if you use secure, like SSL over WebSockets, O2 will not drop them. It'll be an established connection, and they won't ditch them. But if you're doing anything for mobile, you have to consider automatic reconnection. If you're using vanilla WebSockets, you have to code that stuff yourself. If you're using something like Socket.io or Primus, which I'll show you, they'll handle reconnecting for you. I've worked on a project where we were considering using WebSockets for mobile. In the end, we just decided to do long polling because we knew I think there was some reason why they couldn't get an SSL certificate, or I don't know why, but a year and a half ago, we basically decided to go with long polling instead of WebSockets. I think it's because they had a Ruby server in between, and they couldn't handle the WebSocket connection. They could handle normal HTTP traffic. So in that case, we used long polling. So authorization of sessions. The point about this is that when you have a page that has a WebSocket on it, so think the scores page, there's actually two requests that go on there. One of them is the actual web page, which has typically a cookie that the server can see, and it says, yep, I can see that this is the scores page, and I'm only going to send them this data. The problem is there's a second request, which is the actual WebSocket. And you need to be able to say this WebSocket has the same session as this web page. Like, it might be an admin view, it might be their logged in view is slightly different. This used to be hard a few years ago. Now there's just middleware that you can just add in. Again, I'll point at Primus because it has a lot of good middleware. You just drop in a piece of middleware and you'll get the actual session inside of the WebSocket connection. It'll just put those things together for you. And then you have scaling. And I've tried to put together a scaling demo, which I should have time to show you. This is still fairly new to me as well. So so the scaling on two levels. One is on the client side and one's on the server side. So the client side is because the RFC for HTTP 1.1 states that a browser should only make a maximum of 2 concurrent connections to any origin. Okay, that's not a lot. That's 1 WebSocket and 1 request. Forget images. Like, the request dies and then it will keep requesting your images, but it won't be able to do any kind of parallel connections for your images and so on. Now, Chrome, as of 99, like quite a few years ago, have implemented 6, but they have a 6 maximum at the moment. So it means that you can only have 6 concurrent connections to your web server through Chrome. And IE, Firefox, and so on, they have different numbers, but the point is it's low. What this means is, say Facebook, for instance, which has chat built in, they have persistent connection to their server. If you have 7 tabs, if you go for a 7th tab while you have Facebook open, if you make a 7th tab to Facebook, the browser won't make the request for you. Okay, it will today, but if they'd implemented it like just pointing to one single server, it won't have completed the request. Okay, it will just sit there saying, waiting for free sockets. Let me just shoot forward, actually, to show you what... The solution is to basically alias your CNAMEs. So what you do here instead of connecting to like websocket.example.com, you just generate a random number, stick that as your CNAME, and alias that on your proxy. So what I mean is if you have anything like CNAMEs alias to your domain, so for instance for JSBin we have rem.jsbin.com, aloe.jsbin.com, we have all the usernames.jsbin.com, they all point to the same server. There's not thousands of records for each one of them. And doing that kind of thing in your host file, I think, is pretty straightforward. So having an alias that you can support where it says anything.example.com will land on my server. That will get around the maximum 6 connections. Okay, it's pretty straightforward. Feels a bit dirty, but it's totally good. And then scaling on the server side, there's two parts to it. One is simply scaling horizontally, like how do you do that? How do you deal with the traffic? Same way as you would with a regular web server. You put a proxy in front of it, so HA proxy. Nicholas Zakis has a really good article, which I'll link up again, on how they use Node and HA proxy for, I think it's Box or Box.com, I can't remember the domain. There's Node HTTP proxy, which is a typo there, but that's a Node-based proxy which will do that work for you. Nginx can proxy for you and so on. So you just do it the same way as you would a regular web server. The extra part is putting WebSockets together at the back end. Like, how do you get them to find each other? If you connect on one origin or one server that's like port 8000, how does it know to broadcast to the other web server that's on port 8002? Okay? Good question, I hear you saying. My slides are slightly out of order. So, give me 1 second. Okay, so the solution is to use, the solution I'm using at the moment is Primus with other pieces of middleware. So, again, the same library. I'm going to show you code that goes with this as well. So I'm using a piece of middleware called emit, which will let me emit named events. Metroplex and Omega Supreme. If anyone likes Transformers, then you've figured out the theme. It's not very easy to Google for. You get a lot of Transformer fanboy crap. Metroplex, what it does is it uses a Redis server, and when you start up your WebSocket server, it registers itself with the Redis server. So everyone talks to this one single Redis server. So you've got server A, B, and C. They all register with your Redis server. You then say to it, you say to the Metroplex, list all the servers that you have registered because I want to go and send messages to them. So there's one simple call, and it'll give you back an array of servers. Omega Supreme is a way of forwarding messages onto that server. So once you get that, like the WebSocket server is running on A, you ask Metroplex what the other servers is as B and C, and then you say, using Omega Supreme, forward this message or forward this broadcast onto B and C, and those connected WebSockets will get those messages. So this is what it will look like. So imagine there's a proxy between these arrows so that it just looks like one domain, but I've scaled horizontally, okay? So I've now got 20 servers instead of one. So they're all connected to some random machine, and if I need to do a broadcast, this client sends a message that is going to broadcast to every other connected WebSocket. So we've got this primus metroplex.servers, it returns an array of servers, I do servers.for each, and I forward the message onto each one of those servers. And the server that actually ran that code works out who to forward it onto, and the messages go back up to all the other machines. The point being here is you can take your Heroku slider, you can drop on a 20, and it should just scale and send out to loads of machines. Okay. So, live demo again. I'm hoping this works. You just about see that. Yeah, okay. So I've written like a really simple little editor. What you can't see very well, but I'm going to just zoom in, is that's running on port 8001, okay? So I'm going to spin up Firefox. Yeah, we've done with that game. Great work. And so that's Firefox. I'm just going to put that over to the side. Put this one here. Thanks. So these are both running on the same port. Can you see that? Yeah, 81. Okay, so they're both running on the same port. The server is running on the same port. So the point is, this is server A. Now if I run Firefox on server B, is it running? Sorry, let me check. I'm supposed to have 4 servers running. Well, you can see server A working. This is also why they say at the Academy don't do live demos, because occasionally it does fail, even though it worked in the back room. Should I just restart everything? Yeah? I've got 4 minutes, 30 seconds, I can restart everything. Whoa. Okay. I don't know, Redis. I don't know how to kill Redis. Redis. Delete. Yeah. All right, let's try this again. Just do it to your servers. Okay, so use local storage to run my thing again, to restore the code. Oh, yep, okay, so, you see that? This is port 82. Okay, so exactly the same code is being pushed up. Okay, and this is an example of scaling the web servers horizontally and using the WebSockets all pushed back up again. So what that looks like, since I have 3 minutes, is this. Okay, so this is the server side. So the server side, it gives me server. So this is the HTTP server, and I've got the Redis database being passed in. So I'm going to call the setup function, and then I'm going to say, so I get Primus back from the setup function. So Primus is just the module Primus. And on a new connection, I'm going to call this connection function. So setup basically creates a new Primus instance based on the HTTP server, so it will wrap around the HTTP server. I'm using the WebSockets middleware adapter. The difference between Socket.io and Primus is that Socket.io will try and choose the best technology for streaming, whereas Primus will let you choose which transport mechanism you want to use. So you can use Socket.io as a transport mechanism. You can use WebSockets. You can use Fay. You can use Browser Channel, which is Gmail's version of Sockets. A whole bunch of different things. So it's pretty high abstraction, but it gives me a lot of nice little features. So I've chosen WebSockets here, and I'm giving it the Redis database. And then this is where I'm adding in the middleware. So I'm adding in this Metroplex, a Mega Supreme, which you can't see. There you go, Mega Supreme. And then the emit, I pass back my Primus server. Okay, so it's now ready. This middleware just kind of hooks in and upgrades Primus for me. So when I connect, I listen to, so I get the Spark. Again, I think it's a transformer thing. I get a Spark, and then I bind for particular events. So code, cursor, and response. So those are the 3 events I'm listening for. I'll talk about them in a second. And then I'm going to immediately emit an event, which is the ID of this particular Spark. So the ID of this particular socket, it will know it's an ID. I'm going to push the port up, which, because of the contrast, you can't see anyway. And I'm also going to broadcast a request event to that particular Spark. This request event, it's a way of communicating to the main editor, which is this one. And it's saying, there is a socket that is interested in your HTML. So it responds with, sure, send this content back to that particular Spark, and it will go back and work its way out. So this is connected to port 8081. The request came from 8082, but because of the Metroplex Redis thing, it just works out where it needs to go. And broadcast is where it works out how to do that. So broadcast type is the event name, so that is like code. Data is the actual code. And I just do this request to get the list of servers. I get an array of servers, and I just use this method, primus.forward, and that forward is what delivers it to the server on 8082 or 8083 or whatever other web server is running, and it just pushes that message back up to the connected client, and that's it. It's as simple as that. It's not a lot of code for something that's reasonably complicated and very complicated to do years ago, basically.